um, Chinese remainder theorem problem. We have a number divided by 3, remainder 2, number divided by 5, remainder 3, number divided by 7, remainder 2. This divided by are these little m's. The little m's are going to be part of the formula that we're going to use. Now you have to double check them to see that they're relatively prime to each other. 3, 5, and 7 are. And then you're going to multiply 3, 5, and 7 to get this capital M. Now the little capital M of 1, 2, 3 are coefficients we're going to use with the theorem. So this is just going to be, what is that? 35 times 5 is 105 divided by 3. And that's going to be M1 is 35. M2 is 105 over 5, and M2 is going to be equal to 21. And then M3 is 105 over 7, which is M3 is equal to 15. So hold on to these. Going to use them at a later date. Probably the trickiest part of this is finding this little x1, x2, x3. Here's how that works. You're going to take m1 times x1, and because it's relatively prime, it's going to have a remainder of 1 mod little m1. So 35x1 is congruent to 1 mod 3. Do you agree that's the tricky part? Do you mind if I show the formulas each time so you get a flow of it? So the next one's going to be m2x2 is congruent to 1 mod little m2. So this is going to be 21x2 is congruent to 1 mod 5 because they're relatively prime. That means their GCD is 1. And then m3 x3 is congruent to 1 mod m3, and that's just going to be 15 x3 is congruent to 1 mod 7. They're relatively prime, so they have to have a remainder of 1, GCD of 1, a GCD of 1. And so this comes from the GCD of 1 formula in the proof. All of these are done by inspection. Okay? Are you okay with the setup for that? That's the hard part. And I think this can be a little awkward too. So if x1 was 1, is 35 minus 1 divisible by 3? Is 35 times 2? Is 70 minus 1? 69 divisible by 3? So this x1 is equal to 2. Is 21 minus 1 divisible by 5? 21 minus 1 is 20 divided by 5? Yes. So x1. What will x3 be? Put a 1 in for x3. 15 minus 1, is that divisible by 7? So it is 1. Okay, so we got that. So once you get to that point, you've got all the pieces for this. These remainders are also another variable, a1, a2, a3. And, gee, this is fun. Okay, so I'm going to write the formula out, and then we'll crank this out. So your x is going to be congruent to, you ready? It's a1 m1 x1 plus a2 m2 x2 plus a3 m3 x3 mod capital M, or 105. So now we're ready to plunk these in. X is congruent to A1, which was 2. M1 is 35. X1 is 2. A2 is the remainder of dividing by 5, which is 3, right? Times 21. X2 is 1. A3 is 2 times 15. And X3 is 1. Mod 105. No way is this going to work. X is congruent to 70 times 2 is 140 plus 63 plus 30 mod 105. 140, this is just going to be congruent to 35, right? And this is 93 mod 105. And so this is going to be congruent to 128 mod 105. And would you subtract 105 from that? What do you get? 23. And does 23 work? 23 divided by 3 is 21 with a remainder of 2, right? Or 23 would be 7, remainder 2. 23 divided by 5 would be 4, remainder 3. 23 divided by 7 is going to be 3, remainder 2. It works out.